Hello, sir. This is Mayur Patil, and today our group is going to give presentation on the different types of materials that are actually used to build the exoskeletons. So these are the topics that will be covered in this presentation. That includes the meaning of the exoskeleton, different terminologies that we have used to define the certain properties of materials, then the actual materials that are used to build the exoskeletons, and in the end we are having certain aims of choosing a good material.
An exoskeleton is an external skeleton that provides support and protection to an organism's body. In nature, exoskeletons can be found in various species, such as arthropods, insects, etc. Exoskeletons are an essential adaptation for many species in animal kingdom. They provide structural support and protection for the animal's body, allowing them to move around and survive in their environments. The exoskeletons also act as barrier against predator and environmental factors such as temperature change and dehydration. The exoskeleton is an essential factor in the evolution of various species, and its study can provide variable insights into biology and behavior of these organisms.
So now I will be explaining the different terminologies that we have used while describing the properties of materials. So the first property that we have is the strength to weight ratio. What basically the strength means is the ability of a material to resist the action of the external forces that are applied to it. So to calculate the strength to weight ratio, as the name suggests, we just have to divide the strength of a material by its actual weight. The next property that we have is the yield strength. What basically the yield strength means is the level of the stress up to which the material shows the elastic behavior, and after which the material starts behaving as a plastic material. So what basically plastic materials means is that it is not able to regain its original shape as compared to the elastic materials, where the materials are able to achieve the original shape. So in the right hand side of the screen, you can see the graph of stress versus strain, and where the plastic materials are not able to sustain that much of stress as compared to the brittle and the ductile materials. So the next property that we have used is UTS. The full form for UTS is the ultimate tensile strength, and it is actually the highest stress that a material is able to sustain whenever it is pulled or whenever it is stretched. So in order to define the UTS of a material, you have to just divide the external force that you are applied with the area of a cross section of that particular material. The next property that we have is the seismic performance of a material. What basically seismic performance means is the ability of any civil related structure to maintain the properties related to certain factors like safety, serviceability, and many more. These kind of properties are generally evaluated during the time of an earthquake, and that is why they are known as the seismic performances. So now basically we will be discussing the different materials that are actually used to build the exoskeletons. So the first material that we have is the steel. The basic property of a steel is that it is robust, long lasting, and it is actually able to endure the enormous weights, and that is why it is used in the constructional exoskeletons. Also, due to the excellent value of the strength to weight ratio of a steel, it actually enables us to create the light and the powerful materials and powerful structures that are again used in the construction purposes. Also, the steel has a property of being easily welded, and that is why it actually enables us to build the complex structures and complex designs as well. So as I mentioned earlier that we use steel in the constructional purposes, we can see on the right side of a screen where the external perimeter of a building is actually made up of the steel, and the main function of this external perimeter is to absorb the horizontal actions and provide the energy efficiency to the entire structure. Also, the perimeter that has been constructed, uh, that is actually intended to absorb the various other climatic factors like the wind resistance, the seismic performance, and also the load capacity of the entire structures. So now, as you can see on the screen, we are having a chart that basically describes the different values of the yield strength, UTS, and strength to weight ratio for the steel. So in this yield strength column, As we can see, there are different kind of steels that are available at different strength, different UTS values, and according to those two values we have different strength to weight ratio for that as well. So like there is a huge amount of variety in terms of the strength, and the people can choose the different variety of steel on the basis of the strength that they require. So this is one of the reason that steel is widely used for the exoskeletal purposes. So the next material that we have is aluminum, and like the steel, aluminum is also a strong and the lightweight material, and which is why it is preferred for building the constructional structures and the supporting structures in the buildings. Also, one of the best property that aluminum has is the its excellent corrosion resistance, and that actually enables us to employ aluminum in those areas where the climate is generally wet, or where we want to construct the bridges that are submerged in the salt water. Then also the aluminum has a good value of malleability, and that actually enables us to create the complex design and complex structures. Also, due to the high strength and strength to weight ratio, the aluminum actually provides the support without making additional bulky constructions.
One of the critical components of an exoskeleton is the frame, which provides structure and support for the device. Traditionally, exoskeleton frames has been made from metals such as aluminum and titanium. However, in recent years, there has been growing interest in using carbon fibers to create more robust and lighter exoskeleton frames. One of the key benefits of using carbon fibers in exoskeletons is weight saving. Carbon fiber frames can be up to 50% lighter than traditional metal frames, so that users can move more easily and with less efforts. Additionally, carbon fibers can be made with thinner and more flexible frames, which can improve comfort and range of motion. But not just the weight and flexibility makes carbon fibers attractive for exoskeletons. Carbon fibers are also incredibly durable and resistant to fatigue, so they are withstand repeated use and stress without breaking down. This durability is crucial for exoskeletons. Another benefit of carbon fiber frames is that they can be customized to fit the wearer's body, which means that the frame can be modified to fit their specific shape and size. This customization can improve the support and comfort of the exoskeleton, which reduces the risk of injury and discomfort. Basic properties of carbon fibers can be divided into following categories, and this carbon fibers are being used in exoskeleton.
So, what are the plastic used in 3D printed structure? The first one is PLA. PLA is the one of the most popular material used in 3D printing. PLA or polylactic acid is biodegradable and bioactive polymer derived from renewable resources like corn, starch, or sugarcane. One of the key properties that make PLA so popular in 3D printing is its low melting temperature. With a melting point of around 180 degrees Celsius, PLA is easier to extrude through a 3D printed nozzle compared to other commonly used filaments like ABS. These low melting points allow for high precision in creation of complex design, making it top choice for 3D printing. PLA also has good strength and stiffness for a biodegradable material. Its tensile strength ranges from 17 megapascal to 74 megapascal, depending on the specific blend and processing condition. Next is ABS. ABS is known for its strength, toughness, and resistance to impact and high temperature, making it an ideal material for creating strong and durable objects. We will see the features and benefits of ABS. ABS has tensile strength ranging from 29 megapascal to 43 megapascal, and its young modulus is approximately between 1.79 to 3.2 gigapascal. This makes ABS an excellent material for creating objects that require strength, such as automotive parts and mechanical parts. Additionally, ABS has good heat resistance, making it suitable for applications that require high temperature. ABS is popular choice in 3D printing because it is easy to use and produce high quality prints. It has low melting temperature, which means it requires less energy to melt and form into 3D objects. Additionally, ABS is available in wide variety of ranges in form of color, which makes it versatile option for 3D printing. So next is PET. PET filament is known for its excellent mechanical, electrical, and thermal properties, making it ideal material for creating durable and lightweight parts for mechanical and engineering applications. PAT has ultimate tensile strength of 150 gigapascal and young models of 9 gigapascal, which means it has excellent strength and flexibility. Additional, PAT is fully recyclable and frequently recycled in significant amount. PAT is also known for its exceptional strength and durability. PET filament is popular for 3D printing due to its strength and flexibility. It is commonly used to manufacture durable and lightweight parts, and additionally, PET is easy to print and produce high quality prints with good surface finish.
Textiles and exoskeletons. The uses of textiles enhances the performance capabilities and the physical skills of human beings that use exoskeletons that incorporate textiles. Textiles can also provide a very comfortable layer of clothing. They're responsible for providing a breathable layer between the exoskeleton and the wearer's skin. The user of exoskeleton can move very freely as textile leads to very free and non-rigid movement of the user. As we can see on the right side of this slide here, that we have multiple fabrics that are made from textiles. Moving on, what are the material requirements for textiles? Coming to material requirements, we notice that the textiles must be hard, they must be resistive to wear and tear that comes from repetitive use. It must be moisture resistant. This is very helpful during exercise as sweat does not accumulate and it washes up, the sweat flows away from the textile. The textile should be lightweight and it also must have technology to reduce the weight of the exoskeleton on the wearer's body. A recent technology that is studying this is this chainmail like structure that is made from various textiles. It will be used in future military uses. A few more material requirements. Antimicrobials are used to treat textiles so that there is no risk of bacterial or fungal infection due to sweat, accumulated sweat, as I mentioned earlier. Textiles must be very easy to clean. We must be able to wash away dirt easily, and as it would ensure a long life to the textile and would provide effective protection against pathogens to the user. What are the possible materials that we could use in textiles? Well, spandex, also known as lycra, is used in exoskeletons and it can stretch up to 6 times its length, and hence it allows for a very flexible range of motion. Polyester is also used in various exoskeletons. It's easy to clean. It increases the maintainability of the wearer. It decreases the maintainability efforts of the wearer. Polyester also has very high resistance to UV light, making it very effective in sunny climates. Then it's sunny and dusty environments. A few more possible materials are neoprene. It's a synthetic rubber that provides cushioning and shock resistance to the wearer. It is also highly water resistant, which makes it in turn very usable for wet and humid environments. The neoprene is a thermally stable textile. Overall, the best textile material to use in the exoskeleton will provide flexibility and durability to the wearer. We could see from the graph here that we have a tenacity versus elongation plot for all different fibers. Tenacity is the maximum amount of force with respect to its elongation that a particular textile or any material can withhold before completely breaking off, before the atomic structure of the textiles completely breaks off. We can see that the nylon has very high tenacity, hence it makes it a very good textile that we could use in exoskeletons. We also see that polyesters have relatively high tenacity when compared to its elongation percentage, also making it very uh, ideal for exoskeleton use. Overall, we need a material that has high tenacity and high elongation percentage so that it could be flexible as well as.
So, hello everyone, my name is Swayam, and so today we'll talk about the role of polymers and composites in robotic exoskeleton. So, first of all, why should we prefer polymers and composite over other traditional materials like metals? So, the answer is because they are cheaper, they have more chemical and moisture resistance, and they can have the desirable properties that we need. Some of the properties are given here, like they are lightweight, durable, and flexible. Okay, so the most commonly used polymers and composite material for robotic exoskeleton include nylon, Kevlar, polyethylene, epoxy, and ionic polymer metal composites. So, yeah, on to the next slide. So the first one is nylon. So some of the properties of nylon include nylon has high strength and durability. It has flexibility. It has low coefficient of friction. It is lightweight and it has more chemical resistance. So the following are the mechanical properties of different types of nylon. So as you can see, tensile strength, tensile modulus of elasticity, and tensile elongation. All the properties are given here for different types of nylon. So this nylon is used for robotic exoskeleton. So the next polymer is the Kevlar. So Kevlar is a synthetic polymer with high tensile strength. It has high impact resistance, and it is frequently used in body armor and other protective gears. As you can see in the image, as you can see in the second image, it is being used as a bulletproof vest. So it gives more security to the exoskeleton. So here are the mechanical properties of Kevlar. You can see the tensile strength, or the ultimate strength, is 3000 megapascals. So the next polymer is polyethylene. It is a flexible and lightweight polymer, and it is frequently used in pipes, packaging, and other applications where flexibility and toughness are important. And it is also comfortable to wear and gives the wearer a adaptable fit. So yeah, so the next is epoxy. So epoxy is a thermosetting polymer with exceptional strength, hardness, and resistance to chemical and moisture. So it has high stiffness and low shrinkage. It provides thermal stability. It has electrical resistance. It is frequently used in composite materials, coatings, and adhesives. It provides more durability and strength to the exoskeleton. The next one is ionic polymer metal composites. So it is bio-inspired transducers which resemble human tissue and muscle in terms of their physical characteristics, and they are the potential replacement for conventional robotic actuators in medical robotic applications. As you can see in the first image is of a soft robotic hand made of ionic polymer metal composites, and the second image is of micro machines made of ionic polymer metal composites. You can see the different applications in the different images given below. Yeah, that's it. Thank you.